Day 2 of review of Unit 4. Reminder that next class we will be taking our quiz on Unit 4. These first several problems all ask us to solve a compound inequality, and then we are asked to graph our solution on the number line. We reviewed last class how to graph a compound inequality. We will continue working on that today as well as solving. To solve our compound inequality, this one we've got two separate inequalities connected with an or in between. We're just going to solve the inequalities one at a time and then keep the word or in between on our answer. So 4 minus 3x is greater than 28. We're going to ignore the second part over here and just focus on the first one. We can do that by subtracting 4 from both sides. Sometimes we flip our inequality, but not when we subtract, only if we multiply or divide both sides by a negative number. 28 minus 4 is 24. I do not flip my inequality. My 3x comes down. That minus sign is connected to the 3x. That's minus 3x here. This means negative 3 times x. We undo multiplication by dividing. We're going to divide both sides by negative 3. Negative 3 divided by negative 3 cancels, and I just get x. 24 divided by negative 3 is negative 8. And I did divide both sides by a negative. This is when we flip our inequality. This second part of the compound inequality we're going to solve by adding 10 to both sides. And dividing both sides by negative 7. Here again, I divided both sides by a negative. That is when I flip my inequality around. Negative divided by negative is positive. 14 divided by 7 is 2. So our solution is x is less than negative 8 or x is greater than 2. To graph our solution, we need to make our number line. I'm counting by 2's. Any x values less than negative 8 should be solutions, so I should shade those in. Or it's possible that x could be greater than 2. Those should also be solutions. X is less than negative 8 or x is greater than 2 with the correct graph there. Question number 2 is a similar problem. We are asked to solve the compound inequality, graph our solution. This one is an AND statement. For an AND statement, remember we are looking for the overlap of the two statements. I need both of them to be true. Again, we solve each one independent of each other. If it helps to cover up one of them, so you don't even have to look at it, that's fine. We are just solving this part over here. I've got x on both sides of my inequalities. Let's move them all over to the same side. We can do that by subtracting 4x. (6x minus 4x is positive 2x. 6 comes down, that's a negative 6. And when I subtract, I don't flip my inequality. Now it looks a lot like the previous problem. I can add 10 to both sides. Positive 2x is less than negative 6 plus 10. And divide both sides by 2. I never did multiply or divide both sides by a negative number. I divided here, but I divided by positive 2. I do not flip my inequality. I get x is less than 2. Now we're going to solve this part. Subtract 8x. I've got negative 4 is less than or equal to 8 plus x. Subtract 8 from both sides. Positive x. Negative 4 minus 8 is negative 12. You can either leave it like this, or a lot of times it helps to put the x in the front. And notice the x is bigger, so the x needs to stay bigger. So there's my solution. If you left this second inequality written negative 12 is less than or equal to x, that's fine. So we've got negative 12. Again, I'm going to count by twos. Now remember, I want both of these things to occur this time. So up above, I'm going to graph x is less than 2. And x also has to be greater than or equal to negative 12. So I'm graphing each one. And I am looking for where do both of those things occur. And notice both of them occur in between the negative 12 and the 2. So closed circle on the negative 12. They're both true at negative 12. The top one's not true at 2, so I have an open circle at 2, and my shading needs to be in between those two things. Number 3, again, we're solving a compound inequality. This is one that has the variable in between the signs. We did it a couple different ways. The first way that we talked about doing it was just looking at that, copying it down over here, solving that part of the inequality, solving this part of the inequality. And then once you've solved the two inequalities, connecting them with an and symbol. This is understood to be an and statement. And that's a great way to do it. I think the more common way of doing it is to solve for p in the middle. And anything I do in the middle, I need to do to both the left side of this inequality and the right side of this inequality. So the first thing we are going to do is add 5 to both sides. And by both sides, I mean I want to get rid of the minus 5 in the middle. And if I add it to the middle, I need to add it to this over here, the left side of this inequality, and the right side of this inequality. Those cancel. Negative 1 plus 5 is 4. Here I've got p over 2. Negative 7 plus 5 is negative 2. I did not multiply or divide by a negative, so my inequalities stay the same. I am dividing p by 2. We cancel division by multiplication. I'm going to multiply by 2, and if I do it in the middle, I need to do it over here, and also do it over here. 2 times negative 2 is negative 4. 4 times 2 is 8. And it does ask us to graph. We'll count by 4s. And notice my p needs to be both bigger than the negative 4 and smaller than the 8. So I want to shade in the values in between negative 4 and 8. Open circle on the negative 4, closed circle on the 8. P needs to be between negative 4 and 8. Bigger than negative 4, smaller than 8. Number 4. Same setup, solve the compound inequality. We're going to graph our solution on the number line. Start by subtracting 5. We're subtracting 5 in the middle. Again, if I do it in the middle, I need to do it on the outsides of the inequalities as well. We're only doing that if I have multiple inequality symbols. 2 minus 5 is negative 3. Negative 13 minus 5 is negative 18. Cancel this multiplication by dividing both sides by negative 3. And again, I'm doing it on the inside, so I have to do it on the outsides as well. Negative divided by negative is positive. And I divided by a negative, therefore I do need to flip my inequalities around. My x needs to be bigger than the 1, so my shading needs to be bigger than the 1, but smaller than the 6. Both bigger than 1 and smaller than 6 is in between the two. Open circle on the 1, closed circle on the 6. And then the last topic, and we have a few examples like this, are these story problems. We are asked to write an inequality to represent the word problem, and then we're going to solve the inequality and respond to whatever prompt there is. And then the word problem says 10 times a number increased by 4 is no more than 24. 10 times a number, we don't know what that number is, so let's call it a variable. I'm going to call it n. You could use x as well. 10 times a number, that's going to be 10 times n. Increased by 4. Increased by means I want to add 4 is no more than 24. So let's put 24 on the other side and let's think about which inequality we should write. So 10 times a number increased by 4, that's this, and here I've got 24, is no more than, if it says that something is no more than 24, 24 needs to be bigger than that thing, or it could be equal to that thing. So 10n plus 4 has to be either less than or equal to 24. So write an inequality to represent the word problem. Did it. Solve your inequality. Let's do that. Subtract 4 from both sides. 10n is less than or equal to 20. Divide both sides by 10. How do we get n has to be less than or equal to 2? Solve your inequality. Did that part. And respond to the prompt. Write an inequality that represents all such numbers. That's what we did right here. So that number has to be less than or equal to 2. Number 6, write an inequality to represent the word problem. Solve your inequality, respond to the prompt. It says Leah needs at least $240 to buy new headphones. So she wants to buy some headphones. She needs at least $240. She has already saved $52 and earns $22 for each lawn she mows. So she needs at least $240. She already has $52, and she gets $22 for each lawn she mows. Question wants to know, what is the minimum number of lawns she must mow? She's trying to save enough to buy these headphones. She already has $52. She gets $22 for each lawn that she mows. We're looking for the minimum number of lawns she must mow to have enough to buy her headphones. All right, so write an inequality to represent the word problem. So sounds like she's saving money. So let's start with money saved. And she needs to save at least $240. And then we need to think about which of these things needs to be bigger. Well, if she's going to have enough to buy the headphones, her money saved has to be bigger than, or it could be equal to 240. The amount she earns has to be greater than or equal to 240. And then the money that she already has $52, so let's put that on there. Plus, she's making $22 for each lawn. 22 for each lawn, so 22 times X, where X is the number of lawns. She has to mow them, though, I guess. Number of lawns mowed. So I have 52 plus 22x is greater than or equal to 240. There is our inequality to represent the word problem. Solve your inequality. Let's do that. Subtract 52 from both sides. I get 22x is greater than or equal to 240 minus 52. $188. And then divide both sides by 22. $188 divided by 22 gives me 8.545. And let's assume she has to mow the whole yard. She can't mow half a yard or 3/4 a yard or a fraction of a yard. So what is the minimum number of lawns she must mow? The number of lawns that she mows has to be bigger than or equal to 8.545. So the minimum number that she can mow has to be the closest integer to 8.545 that's bigger than that number. So she needs to mow at least 9 lawns. So we wrote our inequality, we solved it, and we responded to the question that was asked. Last one, number 7. Write an inequality to represent the word problem. We're going to solve it and respond to the prompt. It says that George works as a real estate agent. He gets paid $12,500. So that's how much money he makes. He also gets paid an additional $1,140 for each home he sells. So his salary, he has a base salary, but then he gets a commission. He makes extra money every time he sells a house. He makes $1,140 for every home he sells. Question wants to know, what is the minimum number of homes he must sell to earn a total of $60,000? So what is the minimum number of homes he must sell to earn $60,000? It says a total of, I think it might be better worded if it said at least. Because he's okay if he earns more than that. So we are looking for the amount of money that George earns, dollars earned. And we are comparing that to $60,000. That's how much he wants to earn. So money earned, we are comparing to 60,000. And we want to think about which of those needs to be bigger. He wants his money earned to be bigger. It could be equal to 60,000. Think about what he makes money on. He makes money just by working for this company, $12,500. But then he also makes $1,140 for each home. So I'm going to call number of homes H. And solve for H. Subtract 12,500. So we have 60,000 minus 12,500. I get 1140H is greater than or equal to 47,500. And then divide both sides by 1,140. And I get H needs to be greater than or equal to 41.667. Again, he cannot work or cannot sell a fraction of a home. He can't sell 2/3 of a house. I need the number of homes to be bigger than 41.667. 42 is the minimum number of houses that he needs to sell in order to make at least $60,000.